So I think let me address the challenges first, right? There's global challenges, which is common across the different countries, which is the complexity of the systems. We have seen convergence of all technologies, the emerging technologies coming into. There is no difference between analog, digital, and multiple technologies coming together, the communication technology coming together. That presents a huge challenge. Then the platform life cycles have increased a lot. Earlier, we used to define defense systems for 15 years. Now we are looking at 25 years. The current conflicts that we have seen in Europe have, made use some of the older systems, which brings in the obsolescence management. How do you manage something for 25 years when the electronics that support is, we have seen on the other end, the laptops and mobile phones, not even for a couple of years. So how do we manage one end supporting something for 20, 25 years when the electronics and the software keeps changing? And of course, as always, the cost and budget pressure. So the cost to build something keeps increasing, whereas the budget, it keeps decreasing across. And added to that, the time to build is much faster right now. Our customers, the defense companies, the OEMs, us, all of us have to bring in the systems with much shorter time to the market, to our customers, keeping the same quality at the same time. And also the increase in the software, reliance of software, that has changed, which can lead into more simulation, validation, all of that, but that leads to a new challenge of cybersecurity. And then finally, not least, is the shortage of skilled engineers across the world. The aging workforce, especially in US, Europe, creates a lot of system expertise back home. I think all of these challenges we've seen globally. Specific to India, I think our production is not meeting our requirement needs. We are still importing a lot from outside. And there are a lot of government initiatives, but our production has not scaled to meet that adequately. And even we are not meeting our export targets. And also there is slow response of the defense public sector undertakings. So there's been a lot of effort from the government to privatize, to get the private companies involved in the manufacturing. So that's a good step. The other challenge specific to India, there's a huge technological gap, right? Forcing India to rely on heavily licensed manufacturing. We do a lot of licensed manufacture, but that leads to a technology gaps and times of conflict like this, when the political scenario is changing, we are left with our own way to mend or even support this. And we are facing those challenges because we are heavily reliant on other countries. And other challenges, again, Indian ecosystem, it's still very nascent from a defense perspective, even technology IP perspective, right? I think some ways to address some of these challenges, global as well as the Indian challenges, is we need to fully start implementing the government reforms, right? Modernizing the infrastructure. The private companies can jump in more. The government is already helping, and we need to kind of accelerate that faster. We have to have in-house production system, in-house technologies, in India technologies, and vertical integration. And that's why companies like us can help in making sure the technologies are built in India. And I think if you take a step back, we have to think bigger and broader, right? We address problems in a very minute level, but we have to take a step back and say, okay, can we create a Lockheed Martin in India? Can we build technology giants, defense giants in India like that, rather than solving smaller problems, right? We need to solve smaller problems, that's great. But also we need to take a step back and how do we create a Boeing or a Lockheed Martin in India? I think those are the things that we need to look at from addressing these issues. And of course, enhancing the education and training programs. We need to start investing in aerospace, engineering and aerospace professionals with the technology colleges, with the engineering colleges. We have gone too much on the software side over the last few years. We have to come back to the engineering to build this ecosystem. So that's some of the ways that we can address it. Yes, I think there's a lot of emphasis on the green aviation initiatives, right? The overall green initiatives, climate change, and the exposure on the what it has brought in, the aviation industry is not left behind. So there is already a lot of work on developing fuel efficient aircrafts. And there's also about using sustainable aviation fuels. And recently we had one of the major companies completing 100% flight with a sustainable aviation aircraft. So also showing us what this could lead to the future, how the future looks like. There is an industry commitment to achieving net zero CO2 emissions by 2050. And, and already there are a lot of investments happening in SAF, in fuel efficient aircraft. And one of the major contributions of that is going to be the electric propulsion systems, right? There's already a lot of investments going into eVTOL, electrical vertical takeoff and lift, and electric taxis that we'll call for shorter duration, even for the consumer perspective. And we already seen some of the licenses given in US, and in maybe in 3-4 years, we will see some commercial operations both in US and probably even in Middle East. And I hope India is not far away from that. So all of this will help reducing the climate impact from the aviation industry. So about a couple of years back, US DoD put out a list called Advanced Capability Enablers, ACE, which they looked at and said, okay, these are some of those technologies that are going to be majorly impacting any defense system or any aerospace system that's going to be created, right? So these are what you mentioned, and we are all familiar with autonomy, robotics, unmanned systems, unmanned vehicles that we are seeing already, and that has changed how the warfare is done. And we have seen in the Russian-Ukraine conflict how that has changed the whole total. So one is that. Then the sensor fusion. There are various sensors that's there in an aircraft and aerospace system, how that blends and then gives either the pilot or an autonomous system decision-making capabilities, right? And in the advanced sixth generation aircraft that are getting built, for an aircraft pilot, how can you show that in the visor, what relevant information for him to deal with? How do you bring all this information? Sensor fusion. And then, like you mentioned, artificial intelligence and machine learning is changing every industry, and aerospace defense is not behind. How do you use that to make all the aspects from the manufacturing, from the system life to building, creating the wartime scenario and building things faster, right? So that's. And then the electric aircraft that we talked about, that's a huge, how do you combine the engine with both electric as well as fuel or purely electric fuel, hypersonics, then multi-domain operations. It's not anymore a single domain, a land or warfare. It's more of an electromagnetic warfare. Even before the land war starts, you could use the electromagnetic spectrum as a war. And then with all of this comes the cybersecurity with data sharing, right? So these are some of the advanced capability enablers. But there are other things that are happening in the industry too. The large satellite constellation, if you look at from a commercial aerospace perspective, like what we are seeing in the SpaceX Starlink, or what China has already done with so many LEO satellites addressing the communication. Additive manufacturing, 3D printing, that's again revolutionizing the aircraft component production as well as the aerospace. Recently, we had one of our customers in India, Agnikul, using 3D printing for one of their launch, and they had a successful launch just a week back. So that's going to play a big role. Quantum computing, that's another area that's how do you create quantum resistance algorithms and unparalleled processing power, as all of this requires a lot of processing, and how you can build. And today, artificial intelligence, as it requires a lot of processing power, and it's centralized, and it requires humongous power requirements. So now with quantum computing, some of those could be addressed in within the aircraft or on the edge. So that's, and then augmented reality and virtual reality technologies. that's going to pay. And all of this leads to the digital twins and digital transformation. So these are some of these technologies. As we have seen in the past, a lot of these technologies actually get advanced in the aerospace defense domain, and then it gets spreads to the other areas, and it helps the world, humanity, and other fields equally well. And these are the areas that actually, which are going to have a huge impact, not just in aerospace and across. And in India is not far behind, right? We are already seeing a lot of AI happening within India. And then even the India's indigenous drive, our recent LCA and our next project, AMCA, actually incorporate a lot of these things, including stealth technology and other things into the program. So India is not far behind, but I think we need to ramp up, like I said, address some of the challenges that specific to India to create our own technology ecosystem to address some of these and take help of this, some of this in the aerospace defense industry. Digital twin is, you could start at component level to the whole aircraft level. You could create a digital model for everything. And that helps starting from the design and the prototyping and the testing, right? One of the areas where it's going to increase a lot of efficiencies in the testing. Today, even in LCA, if you have to create an LRU and you want to test it, you can put it in a test rig, and then you can do a test flight. A test flight costs lakhs of rupees for just 1 hour of test flight. And if you find something there, you have to come back, fix it, and again go back and do testing. So I think the digital twin that is going to reduce that by almost about 80 to 90% of that test flights that are required, which you can figure out in the design, in the rapid prototyping, and in the testing and modeling stages. Find all of you. Still need a test flight, but what we need to do is 10%, and that's going to help us in cost, in efficiency, in time, and also even the sustainable, making it more sustainable, right? So that is on the design stages. And then on the manufacturing, right? So it is going to look at making design modifications faster, optimizing the schedules, optimizing asset availability. And then once you manufacture, like you mentioned, predictive maintenance. So you could, using the digital twin, you could actually feed the data from the flights back into your digital twin and then manage and maintain that asset. You can know when it requires servicing rather than pulling it out, or avoid failures as it's happening. So that's going to significantly lower maintenance cost and downtimes completely removed if we have appropriate digital twin, which is a complete closed loop from the digital twin going to the actual, and then from the actual going into the digital twin data being fed, right? That's on the asset side across, whether it's a defense or a aerospace equipment, and especially in aerospace with the rocket launchers and with multiple satellites, this is going to play a very, very important role, because once it goes up, there is no way of managing it. You have to make sure the satellites and what you want out of the payloads get the maximum out of it. And that's where digital twin is going to play a big role. This is on the component and the asset level. You could take a step back and also look at the mission planning, right? The training of our pilots and overall operations, and digital twins and digital technology is going to help that lot. We're already seeing a lot of technologies coming in. As the technology matures, it is going to bring down the innovation very high, bring down the time, making it faster, and also overall operations more efficient. I think India has a huge plan to be a developed countries, right? Our PMO has laid out, and then if you look at some of the countries, developed countries like US or some of the European countries, aerospace and defense industry plays a huge role in that. They not only have a huge economic impact, contributing more than $550 billion in US, but also becomes a major source of technological innovation with spillovers into other industrial and commercial sectors, right? So I think that is where I think India's path is very open. We have world over innovation in different sphere in the past couple of decades, and we have seen a huge buzz in the new space and defense areas globally that has happened in the last couple of years. India has inherent advantages. We have one of our top engineering resources. We can actually create moonshot companies and products by thinking broader, right? So the Indian government plays a vital role in that because the policies are very important. There are already programs like Make in India, Digital India, which encourages indigenous manufacturing. The government has increased our FDI in aerospace defense. We have seen more of the foreign companies collaborating with bigger companies. We have seen already some JVs with Boeing and Tata, with Airbus and Tata and some of the other companies. I think that's a sector that will continue to grow. As of last year, I think there were 600 and approximately industrial license given and 360 companies already in the defense sector setting it up. We have the new space initiatives, which we have seen a lot of new space companies, startups, which working alongside ISRO in a good way, as we have seen recent Agnikul launch and working together. So I think we have to continue on this path, right? There are very good starts, but we have to continue on the delicensing, deregulation, right? Export promotion. I think government should make this industry faster, better, and easier to do stuff, not just for the startups, but also for established companies. And without that government support, we will stall, or the growth will probably take more years. I think this is a place where government can really help. And I think government has taken right steps, and there is more we could do in this. And even the state governments, I know Karnataka government has a aerospace defense policy, which they have put in, where their defense parks that has been given. I think this we have to work in tandem with the central government and the state government boosting. And like I said earlier, we have to think broader. I think we sometimes think very individual problem or individual component level. We have to take a step back, and how can the industry and government policies and how can we create a next SpaceX or a Boeing or a Lockheed Martin in India? Can we create these moonshot companies in India? What is required both from the policy level, from the funding level, from the education level, and how do we bring this together? And that's the blueprint that we need to create. I think we need to create in the next 20, 30 years, a Lockheed or a Boeing or a SpaceX in India. So. We have seen over the last couple of years, with the regional conflicts and the geopolitical issues, things change fast, right? I think in 2024, we are in the place where, as we have discussed about, a lot of technologies are converging. AI has matured. Hypersonics, we have already seen some test flights on hypersonics. eVTOL, we already seen some demonstrations of eVTOL, electrical vertical, e-taxis, there already been some demonstrations, sustainable aviation. So there's till over the last 5 years, the technology as well as the geopolitical situation has moved in a way. I think 2024, 2025, we are in a pivotal moment where this could be utilized and accelerate how the whole industry is going to grow, right? So I think we need to continue on the same path. From an India perspective, I think we need to focus how do we create this in local companies, technologies within the country so that we can think of a next 20, 30 years managing this. We already have the other areas with the cybersecurity that we have seen, and we have some good cybersecurity companies here, but we are lagging behind that. So that's another area that we can trend up and go. Overall, the last 5 years has created, with the advanced capability enablers, with the new technologies, with the challenges that we have seen overall, this is a place where all of this you could see an exponential curve taking off. I think we're going to remember 24 or 25, these next 2 years as going to be the place where things completely changed, and especially for the aerospace defense industry, both globally and in India. I believe that. And next 20, 30 years, I strongly believe this aerospace defense industry, especially in India, is going to play a huge role.